because of the 40 minutes?
Yeah, every 40 minutes it will get disconnected. As Sujata madam
Okay.
है ना, तो मैंने अपना link डाला है.
Okay.
Today Sujata madam is not here, so I have given my link.
Yeah.
So we need to get
Yeah.
reconnected with every 40 minutes.
Okay. Okay. So, so assembly cost, labor and tooling equipment. Overhead is support. Include various indirect expenditure. Okay. Not tied specifically to materials or labor, but for necessary for man and depreciation, maintenance, quality control, production supervision, and other administrative. Okay. So this is very, very important. So component costs, part purchase from supplier, custom parts being made, assembly cost, overhead. Including, overhead will include even legal and other things, okay? So you need to estimate the manufacturing cost, reduce the cost of components, reduce the cost of assembly, reduce the cost of supporting production, and also consider the impact of design for manufacturing design on other factors. So goes through a kind of a flow chart, estimate the manufacturing cost, reduce the cost of components, reduce the cost of assembly, reduce the cost of supporting production, and consider the impact of design for manufacturing, recompute the manufacturing costs. Good enough? No, go back and modify, and this has to be done. And actually, this is also very important to create the bill of materials, because bill of materials is required, BOM is required to calculate your revenue and profits and whether it is sustainable. So list all materials, parts, and sub-assemblies for the manufacturing of the product. Critical document for manufacturing. It is used to track inventory, plant production, estimate cost. So how much inventory to be maintained? Do we maintain a lot all the time? Or the consumption during the manufacturing will go a particular way? Then you try to get the inventory in a regular manner, because if you buy inventory, you maintain inventory, you have to pay money upfront, and that is a cash outflow. You may not have that kind of a cash flow, so you have to manage this. Now during COVID, that's the biggest challenge. The supply chain was affected. So for me, when we developed the affordable emergency ICU ventilator, there was a particular electronic chip not able to get from India. We had to import from USA. And there was someone traveling with Vande Bharat, and we asked another person to buy it and give it in, I think, if I'm not wrong, Seattle airport. And he was supposed to bring it to Kochi airport. Unfortunately, the two people cannot meet. Then we were left with no choice. We have to go around the way to really make that function happen. So and during COVID and even after COVID, it is yet to recover. The world supply chain is yet to recover. So if you look at the inflation across the world, it is going up because of the supply chain disruptions. The supply-demand equation has changed. Demand is more, supply is less, or not meeting the requirements of the demand. And that's why all these are to be discussed. Our students should know. We ourselves have to know. Our families have to know. Our children have to know. And they'll become better citizens for developing India. And most times people discuss, see, for example, oil price, why it is high. Now, in India, the oil price is going to come down. There is a speculation like that because they could recover whatever was lost. So it's a business cannot continue unless there is a profit. We have to accept it. So, for example, Singapore to Kochi flight is, earlier I could get it for $300 or $500. It is equivalent to something like 20,000 rupees or 30,000 rupees. And post-COVID, when I traveled in December 2021 and later on, that was 1 lakh Indian rupee or 1.5 Indian lakh rupee, 2 times or 2.5 times, because they lost a lot during a period and they had to get it. So, and this demand is small. And so all these are market trends, and we need to understand the market trends and accordingly appreciate what is happening. So bill of materials is very important, then fixed and variable cost. And this is very crucial. Fixed cost is fixed regardless of the number of units. For example, the injection mold for mechanical, say for robotics. So I had several components for my floor cleaning robot, and then the injection molding molds were to be created. You have to pay upfront. It's very costly because the mold has to last for hundreds of thousands of making copies to be made with that mold. So it should be durable and quality should be assured. So you cannot compromise on that. So that is an upfront. But once you make it, you don't have to change it generally unless there is a design change. But variable cost is the raw materials. If you make 1,000 products or a product in 1,000 quantities versus 10,000 to 100,000 to millions to billion, the raw materials cost will go up. So you need to know the fixed cost and the variable cost. So then only we'll be able to create the or arrive at the bill of materials. And this is an old slide. I mean, the numbers may change or the cost may change, but the concept is the same. If the cost of mold is very high, say $10,000. Okay. So injection molding is not recommended for small number of units of production, because small number of production machining is better. But if you say there is an optimal size like 1,000 units, this may vary from different units for different kinds of complexities. And 1,000 units, below 1,000 units, better to go for machining, above, better to go for injection molding. Because the cost per unit production for machining is 10, but for injection molding can be 1/10. And then you have to really do the optimization. And then design for assembly, minimize parts count, encourage modular assembly, stack assemblies, eliminate adjustments, eliminate cables, use self-fastening parts, use self-locating parts, eliminate reorientation, facilitate parts handling, specify standard parts. Very important. So for example, on the left side, you have 2 screws for this. In order you have to have 2 screws to buy, then someone has to really tighten the screws, the time required. Instead of that, why not on the right side, you fasten it, auto lock. And if you look at the cup here, you have multiple parts and you have to assemble it. You have to make them manufacturing this separate. Instead, go for a single one. Of course, some people want to buy modular one, different colors. That's a different issue. And in olden days, you remember in at home, when my grandfather was there, a radio required 6 or 8 battery cells. One by one, we have to insert it. And all this require time to pick, orient, insert, and make it work. Instead now, a single battery with the same capacity. Similarly, if you look at it, the 6 knobs at the top, instead of putting one at a time, put them together, sub-assemblies, easy to assemble it. So you have to ask for each part in a candidate design whether the part needs to move relative to the rest of the device or not. Does it need to be a different material because of the fundamental physical properties? And does it need to be separated from the rest of the device to allow for assembly, access, or repair? If these questions give you an answer no, then combine the parts with another part in the device and make it a kind of a sub-assembly. So that is the question. And another part is here on the left side, you have 4 screws. You have to pay for the 4 screws. You have to spend time for assembly. You have to spend time for disassembly. So why not change it to something of this kind? And on the left side, you have different sizes of the screws. If you have different sizes, you have to have different inventory management. You have to put them in different boxes. Then you have to really choose how many big, how many medium, how many small screws are required. All those are decision making. Who will do that? Machines or people? You need people and machines for it. More investment. Instead, use the same screw everywhere. Of course, there will be some situations where same screw may not be possible. Very small screws may be required. That is inevitable. But as far as possible, standardize. And in olden days, in my childhood, I have seen this. You have the yellow, red, and blue, wires for the video, and the left audio and the right audio. And it was really getting damaged, not useful. So why not combine it? And also this one, it was very difficult. And this is another one. If you have a very circular one, disc, you might have seen that, in my entire PhD thesis from IIT Madras as early as mid-1990s, still lie on a tape like this. It was a mainframe system, and I bought it. It is still there. I never used it. Now, if you have something circular, how do you hold it? Because there are two, fasteners or alignment openings, the circles here, small circles. And that if you don't hold this disc properly, you'll take more time to align it. But if you have cut at the top and bottom in parallel to the line joining these two alignment circles, then it is easy to pick, easy to position. Very simple. And this here also there is another one. You have something like a lock mechanism, white here, and there is a black one here. I have opened one of this. And if you don't have this color difference, it'll take a lot of time to see the other way, put it the other way. And it's very tough. So you have to be very careful. So minimize parts count, maximize ease of handling, maximize ease of inserting. That will lead to lower labor costs and other indirect benefits. And there is DFME for software development, design for manufacturing and assembly. Now there is one for civil engineering also. So I've been part of a wider discussion in terms of how to automate civil construction, because getting people to do the things is not easy, and the manpower costs are increasing, post-COVID especially. And building information management software is also the BIM. So how to use BIM to really optimize? So you can look at those who are from civil engineering, and there are other design for manufacturing, for electronics, electrical, and other software. So how do you compute assembly time? Now, when my robot was being manufactured in China, they calculate for each and every component handling time and insertion time, that is assembly time. Very important. I'll show in the next slide some of the things. This is, say, CNC machining, numerically controlled. Fixed cost, setup 0.75 hour at $60 per hour. This may be an old data. Tooling, programming 0.25 hours at 60 per hour. Variable cost, material, $9 each. Stock, 1.11 kilogram of 6061 aluminum. Processing, 6 minutes per unit. at 60 per hour. Volume, if you make one, $75 unit cost, 10, 21, 115, that is economy of scale. So you can see it everywhere. All the details are there with the manufacturers. Now this is injection molding. There is no setup fixed cost for this cup. Tooling, $18,000, 8 cavities per mold, no actions. Materials, 0.075 each dollar, 45 gram of linear low density polyethylene. 10,000, 1.91. 100,000, 0.29. 1 million, 0.13. That's a unit cost. Similarly, you can see everywhere. So you need to position from your cash flow and your marketing requirement, sales requirement, where do you want to position it? How much to make? You cannot make it upfront, or you can have quarterly targets and to meet annual target. Similarly, stamping. Setup, no time, no cost. Tooling, $22,000. And 100,000, 1 million, 10 million, the cost reduces a lot. And then this is liquid material is poured into a mold. Again, the tooling requirement is that there is no setup. Then variable and processing and the cost 10 to 100 to 1,000, from $180 per unit to $2.71 per unit. That's the kind of economy of scale required. Assembly costs, it's very interesting. So if you look at the torch, handheld torch, 16 parts, unique parts 12, number of fasteners, no. Total assembly time in seconds, 125.7. Slowest part will take 9.7 seconds. Fastest will take 2.9. So all these for everything to be arrived at, to be used. So then the strategy is contingent, corporate strategy, product strategy, production strategy, and that will contribute to the design for manufacturing strategy. And in order to really make it happen, there is what is known as industrial design. Creation and development of concepts and specifications which will optimize the function, value, appearance of products for mutual benefit of both user and manufacturer. So there are 5 goals: utility, appearance, ease of maintenance, low cost, communications, corporate design philosophy. So when we designed and sent this design files to the Chinese manufacturer, they did not accept it. And it has to go through industrial design. So our industrial designers were in London at that time. And it's very costly. If you have an industrial design experience certificate, your salary is very high. You can charge a lot. And in India, a lot of people are into this space as well. Industrial design can be for mechanical, electrical, electronics, and even architectures in civil. You can see how much they charge. So all products to be used, operated, and seen by people depend critically on the industrial design for success. 2 dimensions: ergonomics, all aspects related to human interface, aesthetics, visual, image, fashion, etc. So ergonomics needs ease of use, ease of maintenance, number of interactions for various functions, one click, novelty for user interaction, safety issues, aesthetic, visual, pride, image, fashion, team motivation. Analyze the level of importance of all this to be understood. And investment, direct cost for industrial design, direct cost, manufacturing cost, time cost. Then to benefit is to increase the product appeal, increase the customer satisfaction, increase the corporate brand identity, increase the market share. So the process of industrial design involves investigating customer needs through user interactions, create form and user interface, that is a conceptualization, have soft models, you can have some kind of preliminary refinements, and create then hard models, further refinements and final concept selection. Then the drawings and models can be controlled, and then coordination with within the team. So how do you manage and assess the industrial design? So technology-driven products versus user-defined, designed, driven products. So industrial design comes very early in the product development process for user-driven products because users have to use it. So to be very careful about it. So you have to assess the quality of industrial design, quality of user interface, whether the product has an emotional appeal and able to maintain, repair the product, and appropriate use of resources, and how do you differentiate your product from others and be able to relatively establish the importance of the performance metrics. So you can look at Apple and others in terms of industrial design. If you look at Apple, why they have really done it in that manner? Apple iPhone, iPod, very unique, very unique. They looked at the design. I mean, if you look at it, the users may not know what is the best use for the users. And the best use for me may not be the best use for you. But on the average, for everybody's use, what is the best? That's what Apple has really brought in. So you have to really see what, I mean, you may think about it if you wish to, right? Now, a design consists of the visual ornamental characteristics embodied in or applied to an article of manufacture. Okay? A design is manifested in appearance. Design pattern relates to configuration or shape of an article, to surface ornamentation applied to an article or to a combination of both. So Apple has a lot of design patterns and many people have it. Most of the times, the design patterns are very crucial. So how the design patterns are granted? It is an invention of a new original ornamental design of an article of manufacture. What it does, it protects only the appearance of the article and not the structural or utilitarian features, only the design. So if you remember when we talk about the patents, Apple versus Samsung litigation, Apple used the design pattern to get into a legal tussle with Samsung, and they did not go through the structural part or the utilitarian feature. Utilitarian means how it is being utilized, what are the components and user interfaces. They did not go into that. So in general terms, a utility pattern protects the way an article is used and works, while a design pattern protects the way an article looks ornamentally. This is very important. You may look at the design pattern for Apple versus Samsung, which we have seen. Okay, so that is for design for manufacturing. Then design for sustainability is there. Okay, we have to see that in detail. So I have another slide which I'll start. We have 1 more hour to go. Yeah. Design for sustainability is very important now, especially what we are going through. How something that we produce impacts the environment and whether it is efficiently the resources are being used. It is a social responsibility. So I'm very conscious about it. As I said, and my grandmother never allowed me to waste even single grain of rice. And I practice it even now. I'll ask my son to practice, my wife to practice, my family to practice, my cousins to practice. We can all do simple things. And we have to design for sustainability to reduce material waste, optimizing energy consumption, and using eco-friendly materials And also we have to look at the circular design principles in terms of recyclability and disassembly. The footprint, the carbon footprint can be reduced, and to promote sustainable practices throughout life cycle. So that is the crucial part. So I'll start with design for environment. Any comments at this moment?
Anybody,
Okay.
if you have comment? Yes. Huh.
Hello.
Yeah.
I have a question regarding minimizing the parts in the product. So does it affect or does it affect the sale of the product? As in case of Tata Nano, we saw instead of 4 nuts in the wheel, nut and bolts in the wheel, they use 3 to reduce the cost of the overall car. But at the end, what we saw, people will reject the car because of this. They feel safety is the issue in that. Will that affect the sale of the product?
Vidyaji, could you understand? I could not understand. Can you, if you have understood, Vidyaji, can you explain to me?
I will request once again to ask him. I was also not able to listen his voice properly.
Yeah, can you keep it more closer to the microphone?
Yeah. Am I audible here?
Yes, you are.
We can hear you, but the words are not clear.
Can you please post your question in the chat box?
Yes.
Yeah. Okay. Reducing parts in the production affects the sales. Oh, okay. I mean, we have to look at it from the point of view of the product satisfies the user requirements and it is sufficient or not. Yeah, okay, Tata Nano. Yeah, I think Tata Nano is a different scenario, okay? So reducing the parts doesn't really affect unless the parts reduction lead to user dissatisfaction. So people will make sure that even parts are reduced, the users will be satisfied. The functionality is good enough. For example, the traditional remote control of television, you have 1, 2, 3, 0 to 9, and all kinds of things. We don't use most of it. But the latest one, it is just forward, backward, upward, downward, and then okay. With that, and then the mouse to position. I mean, press your thumb somewhere and you move the the remote in the air, and because of the motion with the motion sensors inside, like a gyroscope or accelerometers, you can really position the point on the screen of the television. Now, if you look at the number of parts in the traditional remote control, it's too many, and people don't use it. I never use it. And in the modern remote controllers, it's less. So it is not reducing that. Actually, it increases. If I see a better quality product with reduced functions, I'll buy more. So it can lead to. So, but some of the parts may not be visible to the users. It'll be inside. And what you reduce inside is not visible. So if you reduce, there is no functionality being affected. Then users will not know about it. And if users do not know about it, they don't have to worry about it. So that is the first question. The second case is Tata Nano. Now, Tata Nano is not coming purely from the point of view of design for manufacturing. That is not the reduction process in design for manufacturing, no. So even if you take a BMW, they do design for manufacturing. They try to look at it, how to reduce the parts, and still they have it and they sell it. So even within Tata Nano, they might have gone through the design for manufacturing. That is a different process. I mean, the process, principle will be the same, but why it is being reduced? So I'll give Tata Nano example. They have only one wind wiper. And if you look at the wiper, because if you look at the front glass, it is smaller in width compared to a normal car. So they fixed one single wiper and you can go like this, and it is satisfying. And if you have one single wiper, only one motor is required. And if you have one motor, the weight of that motor is half of two motors. And if you reduce the weight, the oil consumption or energy consumption is less. Then the CC, number of CC will reduce. So it has got a cascading effect. But Tata Nano is not reduce the wheels and nuts and bolts from a design for manufacturing point of view. It should not be seen from high to low. Should be seen from a family of a mother, father, one or two children traveling in a bike. Safety point of view, 2 wheels to 4 wheels, that is an increase. Safety point of view. 2-wheel, God forgive me for saying this, gets into an accident, the whole family will be affected because of the stability issues. A small vehicle. But 4-wheel, the footprint is more, stability is more. And 4-wheel is more noticeable than a bike. If you look at the number of bike accidents in the world, every country is very high. And if you look at car accidents, in comparison per certain number of units of the same 2-wheelers and the 4-wheelers, the 4-wheeler might be less. I don't have data, I did not really search it, but you can find that out. So it is a safety point of view. It was from 2-wheelers to 4-wheelers we went, and not from high level to low level. No, it's a different, it's an innovation for meeting a purpose. And eventually it is becoming more. So if you look at the trend now is electric vehicle. Electric vehicle, the advantage is you have to see it. Making a better and more efficient mechanical engine, combustion engine, requires a lot of R&D. And there are certain companies well established in that. Very difficult to compete. But look at an electric motor. Electric motors are made in bulk by a lot of companies, and they improve it themselves. Now buy that and make an electric vehicle. And you have batteries made by some people. So there is no monopoly in terms of electric motors and electric batteries. So that's the beauty of an electric vehicle. Now, why I'm saying is that is leading to a lot of small vehicles like Tata Nano being produced and designed and produced. Electric vehicle, 1 person traveling alone, 2 people alone, or 1+2 or 1+3, kinds of things. There are a lot of things happening. Did I bring clarity there?
Yes, sir.
Yeah, okay. Any other question? We have 5 minutes, so maybe we'll have questions now before going to the next one. So any other questions?
No, sir, not right.
Yeah, any comments, folks? Anything? Will it be useful to you? What we are doing here?
Yeah, it's about design. We got idea about design of how to start with the design thing. So there are a lot of things about this. You taught and today that design of manufacturing, design for design, and etc. So it gives us a new idea for a project group also, for the BTech project also. So we can guide them in that way, how to go for designing of some particular product. So they can go for design of manufacturing or they can go for design of assembly.
Yeah. So frankly speaking, with this background, which I've gone through in my first company, whenever I look at a space, whenever I look at a utility space, whether anywhere in the world, I always see how much I can reduce. So for example, my traditional house, 180 years old, 1, 2, 3, 4, 5, 6. I removed 7 or 8 doors. These doors are not required. I put arches there. Why do you need the door? In olden days, the privacy part, females, were privately highly conscious. And in my childhood, I've seen females not wearing, dresses above their hip. So it was very important that a lot of doors were there, and a lot of privacy aspects were there. And only when they go out, they wear the dresses. In my childhood, long back, 50 years back. But that all those have changed. Now people wear churidar, for example, and it's very comfortable, or nightie. There are different versions of that, and so the privacy part is different now. Aspect is different. So the way the society is evolving, the practices are evolving, and comfort levels are evolving, and we have to catch up with that. So you can look at your every space in Sweri, whether what can be changed from a civil point of view, or an electrical point of view, or mechanical point of view, or design point of view. And it's a beauty. So in fact, in Singapore, we don't have too many television channels like India. We have only 3 or 4 or 5. Okay, one English, one Chinese, one Tamil, one Malay, and then one for kids. That's it. And I used to watch The Spaces. The Spaces is a beautiful, video, series where they look at how you can transform spaces. And when I became the head of a Gurukula here, I had 26 students and 6 blocks. Each block may have 7 or 8 stories. And one thing I did is I went around everywhere and looked at every space, and I tried to transform them. Of course, I requested money and I transformed it. How to convert spaces for utility. And that's the beauty of it. And here, one thing I can say that we have converted every space for students to use, to sit and study. And food will be provided. They have to buy, of course, at different locations, so the people will be there. We have 1 minute to go. Yeah. So you can look at it. Even look at your own house and homes, and give conscious efforts to understand the space and how to go about making a difference to that space. Okay, it's very interesting. I think we'll stop now and then we restart it, right? Okay.
Yes, sir.